Hi everyone, I'm Ben and this is my final project on procedural terrain and buildings in Unity. Procedural generation is really common in modern games and animation as it allows the developers to create many scenes, assets, and worlds without having to manually place every single feature itself. Some popular examples of this include the maps in Minecraft and the gun generation in most of the Borderlands games. One of the inspirations for my project was this game Townscaper by Oscar Stahlberg, in which he uses a wave function collapse algorithm to procedurally generate cities and towns based off of user input. My goal for the end of the project was to create a procedurally generated town, and so my first step was to create a landscape. To implement my landscape generator, I closely followed a number of videos by Sebastian Log, a popular Unity programmer. For building generation, I read a number of papers, including this one called The Procedural Modeling of Buildings, and also utilized a number of course resources for a procedural generation class at the University of Pennsylvania. I also took some inspiration from how popular 3D software packages such as Houdini and Blender allow their users to create procedural buildings. My terrain generator involves sampling a noise map in order to offset the vertical coordinate of each vertex in the mesh, from which a color map can then be generated from predefined ranges of values, such as from 0 to 0.2 for blue, and so on. The fine detail in the noise map can be created through layering several different octaves of the noise, and the combination of those octaves can be controlled through the lacunarity and the persistence. From there, it's really easy to generate very unique maps by adjusting the noise scale, the offsets, and the height factor multiplication. To approach the building generation, I followed the idea of using a shape grammar to define how a building can be created, and then formalized the grammar that I would be using, as you can see here. In short, a single building can be defined by its wings, which can then be defined by its stories, which are then broken down until we place our walls, windows, doors, and roofs. I made the generator to be able to take in user-specified strategies for each of these parts of the building, which tell the program where to place each asset and what asset to place. For example, a basic strategy of the building wings might be just to place a single wing the size of the building plot, whereas you might tell it to place it in a U-shape or an L-shape instead. This is then extended to other strategies that define where the doors are placed and what types of roofs should be used. For example, this building here is a 4x2 U-shaped building, which is defined by 3 wings, seen here in red, blue, and green. Each wing has a random height between 1 and 3, and its doors are placed on the first level. In addition, the windows are placed with a 50% chance on each wall. To turn my single building generator into a town generator, I started by creating this plot system that subdivides a user-defined rectangle into city plots that can be constrained by a max and min size. Buildings are then placed on each of these plots, generated from a list of inputted building strategies, which can then each be projected onto our terrain surface to create little towns, as you see here. And that concludes my final project presentation. Thank you so much for listening.